Hello everyone, this is Jacob Ames, Applications Engineer with Hawk Ridge Systems, and today we're going to have a look at an often overlooked simulation tool, the Trend Tracker. This tool allows you to record and track simulation results for multiple iterations, making it easy to optimize your designs even without an engineering background. So here I have a basic model of a Craftsman wrench. We've already set up a static study on it, so we have some fixed bases and forces applied. I'm going to go ahead and simplify this model a bit by suppressing some of our text features. And you'll notice that we already have a cast alloy steel material applied, so we can go ahead and just run this study. We're going to get results for our stress, displacement, and strain like you're probably used to. And while this information is certainly valuable, if we were to make some design changes and rerun this study, we're going to lose this information. So that's where the Trend Tracker comes in. We can activate that by right-clicking the name of our study there at the top of our tree and choosing Trend Tracker. That's going to give us a Trend Tracker item in our tree. And if we expand this, you'll see we don't currently have any information. We need to set the baseline. This is going to set up our initial values using the values of our current study. We can see we have mass, stress, and displacement all illustrated by point values on those graphs. Now this is great, but what if you want to monitor additional properties? Well, for that we'll need to establish a sensor. So we'll go ahead and add one of those in. For our sensor type, we'll choose simulation data. We can choose from any one of these items here, but I'm going to choose factor of safety in this case. And we're going to choose to monitor the model minimum for our factor of safety. I'm going to add this sensor in now, and after having done that, I can right-click our Trend Tracker and choose to add a tracked data graph and select our factor of safety sensor there. With this in place, we can now have a look at factor of safety, and the current value is right about 0.92, maybe just a little bit higher. At this point, we can start making some changes and watch the magic happen. I'm going to go ahead and change our applied material here to brass just for fun, and we'll rerun our study. Once this is done, we'll cycle through all those results, and they're going to be added as additional points to each of our track graphs here. Our mass is increased, looks like our stress is increased, and so is our displacement, and unfortunately it looks like our minimum factor of safety has gone down. So this certainly isn't the material to use. We can go ahead and try something else. Maybe we'll do nickel, see how that stacks up, and go ahead and run the study again. With that complete, looks like our mass has stayed about the same, stress has gone down, but our factor of safety has gone down quite a bit, so this certainly isn't the right material to use either. If we'd like, we could go ahead and restore this model to a different iteration. We could choose our baseline, iteration 2, so on and so forth, but in this case, I'm actually just going to go ahead and reapply that cast alloy steel material, and we're going to make some design changes at the model level. So let's go ahead and come back to our model tab down here. We're going to adjust the overall length of this design. Rather than 140 millimeters, maybe we'll choose 100 millimeters. Go ahead and rebuild that. And we're going to increase the thickness a little bit too to hopefully stiffen this up. So rather than 6 millimeters, we'll go ahead and set this to 7 and rebuild there as well. Now with those changes in place, we can come back to our static study. We'll rerun it and see how this compares to each of our other sets of results. So it looks like our mass has been reduced, which you'd probably expect since we shortened it up so much. Our stress has been reduced by quite a bit as well, as has displacement. Our current iteration has the lowest value for displacement, and our factor of safety has been increased dramatically to up over 1.5 now. It looks like it's about 1.62. So the Trend Tracker is a really great way to actually track your results and retain that information. If we'd like, at this point, we can go ahead and open up our trend journal. It's going to open up a Word document that will elaborate on the results of each of our iterations. So you can see we have 4 iterations total here, describing mass, stress, displacement, and factor of safety. So in today's video, we checked out some of the capabilities of the Simulation Trend Tracker. It's going to make it easy to monitor the effects of changes to your design, simplifying the optimization process, and making optimization possible even for non-engineers. If you enjoyed this video, please give us a like, subscribe, or visit us at hawkridgesys.com. Thanks for watching, and see you next time.